Alrighty, our last video was on adding and subtracting fractions that had common denominators. That was for H. And this one will be for I. This is on adding and subtracting fractions and mixed numbers that have unlike denominators. So let's look at a couple of models first of all so we can kind of understand what's going on here. So when we have the two fractions 1/4 and 2/3, we want to add those together. We can't just take this 1/4 and this 2/3 and add them together because they're not alike. What would we call it? Would we call it 3/3? No, because it's not one whole. Would we call it 3/4? No, because it's not 3/4 of our circles. So we need to come up with a common denominator. And so you can see here in our second set of wheels, that we've taken our two wheels and divided them up into 12ths, which would be the common denominator for 4 and 3. And you can see that if I take this section out of this circle, that would be right here. And if I take this section out of this circle, if I can do this correctly, that would be right here. Using that, and then using this, we can now add those two together and get an answer that would that would make sense for us. So we've got 1, 2, 3. We've got 3 out of 12 here, and we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 12 there. And let's just kind of check ourselves here. So if we were multiplying the top and the bottom here by 4 to get 12, 8 would make sense for our numerator. And by 3 to get 12, 3 12. So you can see this is a good picture of what's happening when we get common denominators to add. And so if we add all of these together, we've got 3 12ths here, so we'll take 3 over here, and then we've got 8 12ths here, so we'll take 1, 2, 3, 4, 5, 6, 7, 8. And so we're going to be adding all of them, the 3 12ths and the 8 12ths, and we'll be using everything except that one little 1/12 sliver. And so 1/4 plus 2/3 is going to give us 11 12ths. And again, you just see that with the model, the need for finding a common denominator in order to be able to add or subtract fractions. So let's look again at this model down here for subtracting. We've got 3/4 minus 1/6. And so again, we've got 3 of these sections here, and we want to subtract just one of these little sections here, but we don't have anything common that we can work with, so we've got to change these into 12ths. And so if we change these into 12ths, we can see that we're going to take all of these here, and then for the 1/6 we want, well, we'll take that away in a minute here. So let me, since this is subtraction, so here's our 3/4, but changed into 12ths instead. And so if we multiplied 4 times 3 to get this 12, we'd multiply 3 times 3 to get 9 here. And then we want to take 1/6 away, so we want to take this kind of slice out of there, which would be equivalent to this slice right here. I want to take that away, so we're taking away 2 out of the 12, and that makes sense that if we would change this to 12ths, multiply this by 2, then we multiply this by 2, and so we would be left then with 7 12ths. And again, so we'll just count these 1, 2, 3, 4, 5, 6, 7, so 7 12ths. Again, the model is just to show you the need for getting a common denominator. All right, so we are going to need common denominators to do our work here. So let's look at our first examples where we're adding. So these are our adding examples here, and I'm just going to turn this over so that we don't get confused with our other papers. All right, so my first problem here is that I need to add 5 and 3/7 and 1 and 5/11. Well, I need a common denominator. I think the fastest way to find a common denominator is to take the larger number and list its multiples until you find something that the smaller number will also divide into. so that you know you have a factor of both, or I'm sorry, a multiple of both numbers. So I know the first multiple of 11 is 11. 7 doesn't divide into 11. 11 times 2 is 22. Nope, 7 can't go into that. 11 times 3, 33. Nope, doesn't work for 7. 11 times 4, 44. Still doesn't work for 7. 11 times 5, 55. Nope, not working for 7. 11 times 6, 66. Nope, not working for 7. And finally, 11 times 7, which is 77, obviously will work for both of those because 11 and 7 are the factors that gave us the multiple of 77. Now again, I like to stack my fractions up when I'm working. So I make this 5 and 3/7, and I want to remember that I'm adding 1 and 5/11. I've got to change these fractions to 77s. So I'm going to make an equal sign here. I'm going to carry my whole numbers over so I don't forget about them. I don't want to lose them in all of this work, all of this kind of confusing work here. I need to get denominators of 77. In order to change the 3/7 into 77s, I multiply both the top and the bottom by 11, so I have 33 77s. And down here, 11 then times 7 and 5 times 7, so I have 35 77s. Now we're finally ready to add. Alrighty, so we add the fractions, 33 and 35, and when I add those up, I'm going to get 3 plus 5 is 8. And 3 plus 3 is 6, so there's my 68, that's my numerator. And then remember, we never add these denominators. So that's 77. We worked real hard to get that common denominator. We don't want to lose it. And then finally, we add our whole numbers. 5 plus 1 is 6. We check to see if we can do any reducing, and I can't do any reducing. There are no common factors for 68 and 77, and so I'm done. 6 and 68 77ths is my answer for my first problem. That was a lot of work. All right, my second one here, 4 and 1/2 plus 3 and 4/10. Again, I like to take the bigger number and list the multiples of the larger number on denominator until I find one that the smaller denominator will divide into. And for this one, I'll have to work real hard because 10 times 1 is 10, and of course 2 divides into 10. So I can use 10 as my common denominator, which saves me a ton of work because I don't have to change this bottom fraction at all because it's already in tenths. Top fraction, I need a denominator of tenths, so in order to make that happen I have to multiply 2 times 5 and then the numerator 1 times 5 to give me 5/10 over here. Now I'm ready to do my adding. Remind myself that it's an addition problem. I'm going to add 5 plus 4, the numerators together, which gives me 9. My denominator just stays the same, tenths, and then 4 plus 3, which is 7. So 7 and 9/10. Check to see if I can reduce this fraction at all, and I cannot. That's in lowest terms, and so 7 and 9/10 is my answer for our second problem there. All right, now some fractions without the mixed number part. So we've got 2 over 6, and we're adding 3 over 8. And when I'm dealing with just fractions without mixed numbers, I don't mind them leaving them horizontally this way, but I've been doing my vertical problem, so I'll just keep that up. All right, so we're going to list the multiples of 8 until we find one that 6, the smaller denominator, will divide into. So 8 times 1 is 8. That doesn't work. 8 times 2 is 16. That doesn't work. But 8 times 3 is 24, and I know that 6 is a factor of 24. 24 is a multiple of 6. So I'm going to change these fractions into 24ths. In order to do that, I had to multiply 8 times 3, so I multiply its numerator 3 times 3 to get 9. Over here I had to multiply 6 times 4 to get 24, so I multiply its numerator 2 times 4 to get 8. And now I'm ready to add. Put an addition sign to remind myself I'm adding. And I know that 8 plus 9 is 17, and I don't add the denominators, so I just bring down 24. And I check to make sure that I can't do any reducing here. 17 and 24 don't have any common factors. I can't divide them by the same thing. And so 17/24 is my answer. Alrighty, so now I've got, back to my mixed numbers here, 7 and 1/5 plus 8 and 2/3. I'm going to move over here so I have a little more room. So I've got 7 and 1/5, and I want to add 8 and 2/3. I think I'll go ahead and write my answers next to my problem since I'm getting my work a little jumbled here so we don't get confused. So just a reminder, the answer to the first one was 6 and 68/77. The answer to my second problem was 7 and 9/10. The answer to my third problem was 17/24. Probably if I didn't write so big, I wouldn't have such a problem. Alrighty, so now I'm on my fourth problem here. Now I've got to list the multiples of 5 until I find one that 3 will also divide into. So 5 times 1 is 5, that doesn't work. 5 times 2 is 10, nope. But 5 times 3 is 15, and that definitely works because 5 and 3 are the factors that I use to make that multiple. So I'm going to carry over my whole numbers. My new denominators are going to be 15s. 3 had to be multiplied by 5 to get 15, so its numerator of 2 gets multiplied by 5 to get 10. 5 had to be multiplied by 3 to get 15, so its numerator of 1 gets multiplied by 3 to get a new numerator of 3, 1 times 3. Alrighty, we are still adding, and I'm ready to add. So 3 plus 10 is 13 out of 15, and 7 plus 8 then would give me my 15 there as well. And so that's 15 and 13/15. Now take a break in the video, you try this one on your own, and then come back and see how you did. I'll go ahead and write my answer in here. 15, oops, didn't make my 5 big enough there. 15 and 13/15. Alright, let's see how you did, guys, on this one. So we've got 3/4 and we want to add 2/8. Again, we take the bigger number and list its multiples until we find one that the smaller number will go into, and I love this because 8 times 1 is 8 and 4 does divide into 8. So that means we don't have to change this bottom fraction at all, which is nice. In order to get ace here, I had to multiply by 2. And so I multiply my numerator by 2 to get 6. 6 plus 2 is 8. Denominator stays 8. And of course, when we see 8 over 8, we know that 8 out of 8 is going to be equal to 1. And so our answer here should be 1. All right, a lot of work. Okay, let's look at our subtraction examples. Here we go. Okay, we've got 7 and 6/7 minus 7 1/2. So 7 and 6/7 minus 7 1/2. Let's list the multiples of 7 until we find one that 2 will also divide into. So 7 times 1 is 7. That doesn't work. 7 times 2 is 14. Of course that works. All right. Carry our whole numbers over so we don't forget those. Denominators of 14. 2 times 7 gave us 14, so its numerator of 1 times 7 gives us the new numerator of 7. 7 times 2 was 14, so multiply its numerator of 6 times 2 to get 12. Alrighty, now just a reminder that this is subtraction. 12 minus 7 gives us 5. Denominator stays the same, and 7 minus 7 is 0. So our answer is just 5/14. Double check that it cannot be reduced, and it cannot, because 5 and 14 don't share any common factors other than 1. Alrighty, let's look at 8 3/4 minus 2/10. So we've got 8 3/4, and we want to subtract 2/10. Start listing the factors of 10 until I find one that 4 will also divide into. 10 times 1 is 10, that doesn't work. 10 times 2 is 20, that one works. Alright, so let's use 20. carry my whole number over. This one doesn't have a whole number, so we can put a 0 there if you want to. If you like that placeholder, you can put a 0 there. 10 times 2 gives me 20, so 2 times 2 is 4. 4 times 5 gives me 20, so 3 times 5 is 15. Do my subtraction. 15 minus 4 is 11. Keep the denominator of 20. 8 minus 0 is 8. So my answer, check to see if this can be reduced, and it can't. So my answer is 8 and 11/20. Alrighty, 6/10 minus 3/5. Let's give it a try. So 6 over 10 minus 3 over 5. List the multiples of 10 until you find one that 5 also divides into. Of course, 10 is the golden nugget there. So that's nice. We don't have to change this one at all. It stays 6/10. In order to make 3/5 tenths, we have to multiply top and bottom by 2, and that becomes 6/10. So we've got 6/10 minus 6/10 is 0. So our answer there is 0. All right. 12 2/3 minus 9 2/8. Again, listing the multiples of 8 until we find one that 3 will also divide into. And maybe you already know this one, but 8 times 1 is 8. Nope. 8 times 2 is 16. Nope. But 8 times 3 is 24, so that definitely works. We've got 12, and then 24 over here, and 9, and 24. All right, 3 to get to 24 means we need to multiply by 8, so we multiply its numerator by 8. That gives us 2 times 8 is 16. 8 times 3 is 24, multiply its numerator times 3, and we get 2 times 3 there is 6. Subtraction, 16 minus 6 is 10. Denominator of 24, I hope you're seeing a little bit of some more work to do yet there. And then 12 minus 9 gives us 3. So this is not in lowest terms. That means we're going to have to reduce, but don't forget that whole number 3. We're going to divide both of these by 2. 10 divided by 2 is 5. 24 divided by 2 is 12. And 5 and 12 don't share any common factors except 1, so that's in lowest terms. So our answer here is 3 and 5/12. All right, last one. So we've got 5/6 minus 1/3. List the multiples of the larger number until you find one that the smaller number will go into, and of course that's 6. So we don't have to change that first fraction at all. Multiply 3 times 2 to get 6, so 1 times 2 is 2. So we get 5/6 minus 2/6 is 3/6. And of course 3/6 can be reduced. You can divide both top and bottom by 3, and we have 1/2 there. And so my answer there should be 1/2. All right, guys, we will practice this in class when I see you next time. Hope this made sense. Please jot down any questions you might have and make sure you ask me when we get to class.